Algebra 2. Even though I am on my way to Florida, I can be here with you through the miracle of today's technology. It's really kind of cool. Certainly wasn't available to me when I was in school, but here we go. So we're doing 7.6 today, quadratic functions. Now to analyze a quadratic function and draw its graph, is our goal, and we want to be able to find its minimum or maximum value. It's going to be very, very similar to the work that we did in lesson 7.5. So in the general form, which is right here, I've underlined it for you right there, is one type of form that we might see a quadratic formula, or excuse me, a quadratic function given to us. And that's quite familiar to us. Ax squared plus bx plus c is the standard form that we would use in solving a quadratic equation. Now, if we look at this completed square form, right here, we note that it is very, very similar to the vertex form we learned last section. In fact, if I replace the f of x with y and subtracted k from both sides, I would have the vertex form that we learned last section in 7.5. So we'll be learning and we'll be rehearsing that and learning how to graph from the general form. So let's rehearse this one. Okay, this is not the general form. It looks somewhat like our completed square form or vertex form. So let's replace that f of x with y, subtract 6 from both sides, and look what I get. Gosh, this looks just like, and in fact is, the vertex form of a quadratic. And so from here, I can identify my vertex. So my vertex is -4, 6. And I know that since a is -1/2, the parabola is going to be shaped like that. It's going to be opening up, going down. So now I just want to graph this in exactly the same way that I have graphed it in 7.5. Okay, but I'm going to actually allow you only to graph two other points, one point in its mirror image, just to save a little bit of time, because I think after 7.5 you've had practice in picking points on a parabola. Okay, so our vertex is -4, 6, so we're going to go to -4 up 6. And now let's get a points to the left and to the right of that. So if I have x be, I'm going to try to keep it even because of this -1/2. So if I have x be -2, so what do I have? I would have, I'll do it over here. I would have y minus 6 equals -1/2, -2 plus 4 squared, right? So y minus 6 equals -1/2 of 2 squared. 2 squared is 4. Y minus 6 equals -1/2 of 4. Bring this down a little further. Y equals, this side is equal to -2 plus 6, 4. So I have this value here of 4. And then it's, so at -2, it's 4. And since this was 2 units over here, it's going to be 4 also. It's not supposed to be, it's not, it's supposed to be a nice round thing here. Okay, so we have those points. We have negative 2, 4, and then we had negative 6, 4, and it gives us a nice picture, a nice sketch of what our parabola is. And we could see that the maximum value of this parabola, as high as this parabola is going to go, the maximum value is 6. For the maximum value, I'm picking up the y value. So the maximum value is 6. In fact, we could say the range is y is less than or equal to 6. The maximum value is 6. The domain, by the way, is going to be all x's. There's nothing that, no x that I can't substitute in. Okay, so now if the function is given in general form, it's very useful to know the x-coordinate of the vertex is this formula. This formula is proven for you in your textbook. If you're interested, you can look it up. X equals negative b over 2a. You need to know this. This is the x vertex. Well, what about the y vertex? To find the y vertex, we'll plug that x value into the equation and come up with a y value like this. Suppose I am given h of x equals negative 1 minus x squared minus 6x. Look, that's not the vertex form. It's not exactly the standard form either. So I want to replace h of x with y and rewrite this in the standard form. Rewriting it in the standard form, I get y equals negative x squared minus 6x minus 1. That's my first step. My second step is to identify the x-coordinate of the vertex. And again, remember, this is the formula here that I'm using. You really want to be sure you know that formula. So putting the values in, x equals 6 over negative 2, I get for x equals negative 3 for the vertex value. But remember, a vertex has an x-coordinate and a y-coordinate. So I have to solve for the y-coordinate of the vertex by using this value for x in that equation. This is the same equation. That's this equation right here. That's that equation. Right here. Same equation. And when I plug in the x equals negative 3, I come out with y equals negative 8. This is good news because now I know my vertex. Woohoo. Yes, I know my vertex. Right there, that's my vertex. Okay. So once I know my vertex, what should I do? Well, make a table of values and pick x's that are simple. Now, whenever you're working in standard form, the simplest x that you can pick, as long as it's not the vertex, is going to be 0. Because that's going to be 0, that's going to be 0, y is just going to be negative 1. So let's start plotting some things here. The vertex is negative 3, 8. 8 goes up here. Negative 3, 8. Doesn't exactly work. Okay. Negative 3, 8. And so my x y table has negative 3, 8. And how about some other points? Well, again, if I put if I make x 0 and plug it in right here, what do I get? Y equals negative 1. So I have the point 0, negative 1. But I also have its symmetric point. You see, this was over to negative 3. That's 1, 2, 3 units over. So 1, 2, 3 units over at negative 6. It's also going to be negative 1. So now I have these 2 points. I can sketch my parabola. Okay, this parabola has a maximum. And how great is what's the maximum value? The maximum value that y gets is this 8 over here. Okay, this is the maximum. The maximum is the 8. Again, I could say the range is that y is less than or equal to 8. Now I knew that this parabola, by the way, turned down. It's the same rules about a. A is the coefficient before the x squared. It's like having a negative 1 there, and that of course meant my parabola was going to go down, and it does. Okay, let's do another one. Okay, here again we want to graph this function, and my first step is I'm going to replace this with a y. Sort of almost don't need to do that, but it is in standard form already. So my x vertex is negative b over 2a. Substituting in, x vertex is 2 over 2 times 1/4, which is 2 over 1/2, which is 4. Now to find the y of the vertex, I plug 4 in to the original, or this, I plug 4 in for x over here. And I'll let you confirm this. You're going to get y equals negative 3/2. I'll give you a minute and you can work on that and confirm that to yourselves as you do the arithmetic. Okay, let's plot this. So we have, I can make a XY table, and I have 4 and, what was the vertex? 4 and negative 3/2. So 4, negative 3/2 right here. Should be a little lower. Help them with the smartboard. Okay, and then what did I say was an easy thing to do? Plug 0 in for x. When I plug 0 in for x, I get y is equal to 5/2. So 0, 2/2, 4/2, 5/2. Forgive the, it's supposed to be a half in the middle there. Okay, so then symmetric. That was 4 units here, so I'm going to go 4 units here, and I will have it symmetric right here. And now I can draw, let's come down here. This is draw my parabola. Again, what's the minimum value here? We see it's minimum because the parabola has a low point. And the minimum value is this negative 3/2 because it's the vertex is at its minimum and the vertex was 4 negative 3/2. So negative 3/2 is the minimum. Okay, and we just already did that. We already stated it. And that's it for day 1.